Suppose we have two firms, firm A and firm B. And they compete on the market in terms of advertising, so they decide whether to advertise or not advertise. If both them advertise, the profit for them is, let's say, is $600,000, whatever it is. And the blue pair belongs to firm B, green pair belongs to firm A. If firm A advertises, firm B does not, then firm A will make larger profit. Firm B will be worse off. Similarly, if firm B advertise, firm A not, then firm A will lose off. If both them not advertise, then they can save the advertising expenditures. So the profit for them is this 16, suppose. So now we set up what is called strategic form game in these tables, and you want to observe that there are four important elements here. First, players. Which is firm A, firm B here. Second, there's action space, or strategies. Third, there's associate payoff. Fourth, actually we are assuming that is perfect information. Perfect information means that everybody knows, all players knows about the games. Everybody knows that everybody knows the games, so on and so forth. Alright, given these games, we are interested to predict the outcomes. What's the outcome of these games? And we use what is called Nash equilibrium, invented by John Nash. Nash equilibrium. So it is a strategy profile, a pair of strategy such that given the other players' strategy, nobody has an incentive to deviate. We can use this definition to find large equilibriums, check for large equilibriums. So let's check advertise whether this strategy profile is a large equilibrium or not. So the process of checking for large equilibrium is straightforward. Again, we are trying to answer two questions. First, if given A advertise will be deviate or not. So given A advertise, then we are in this column. Will B deviate from advertise to not advertise? So if B advertise, the payoff is $6. If not, it's just $4. So the answer is no. Then second question, given B advertise, will A deviate or not? Given B advertise, then we are in this row. Given B advertise, will A deviate? So if A advertise, the payoff is $6. If deviate to not advertise, the payoff is $4. Then clearly the answer is no. Given that both are no, we conclude that advertise is a large equilibrium. Okay. So this is indeed a large equilibrium. Okay, let's check. Not advertise. Let's check A not advertise, B advertise. To see, check this cell. Check these cells. Let's see whether this is a large equilibrium or not. Again, we follow the similar process. Given A not advertise will be deviate. So given A not advertise, then we are in these columns. So B so if B advertise, the payoff is $18. If not, the payoff is just $16. So clearly it's a no. Then given B advertise, will A deviate or not? Given that B advertise, then we are in this row. Will A deviate from not advertise to advertise? The payoff of not advertise is $4. Instead, if A switch to advertise, then the payoff increased to $6. So the answer is yes. So now we find that somebody indeed has an incentive to deviate. So not advertise is not a large equilibrium. And similarly, firm B not advertise, A advertise is also a large equilibrium. And by symmetries. Okay, let's check both not advertise. Is this the large equilibrium or not? Okay, similar as do exactly the same sense, answering the same questions. Given A not advertise, will B deviate or not? Given A not advertise, then we are in these columns. So if B deviate from not advertise to advertise, the payoff increase by $2. Okay, so now the answer is yes. And we can actually stop here. to conclude that not advertised is not a large equivalent. But for completeness, let's check. Given A, check another questions. Given B not advertised, will A deviate or not? So given B not advertised, we are in these rows. So A is going to compare this payoff with this payoff. So A, if deviate from not advertised to advertised, its payoff will increase from $16 to $18, increase by $2. So the answer is yes. So then we conclude that this is indeed not a large equivalent. Okay. So you can also check that whether this whether in this game whether firm A and firm B have a dominant strategy. The answer is yes, and they are advertised. And you can also see that if both them advertise, they actually end up in this situation, which is not as good as these outcomes. So there's a better outcome there that they cannot achieve. And we actually call this prisoner's dilemma.